Okay, welcome to the course MGT 7105. The name of the course is Business Intelligence and Analytics Systems. My name is Ahmad Shaharuddin Abdul Latif. So this round we will cover the topic of business intelligence and data warehousing, which is the second topic of this course. Okay, we will proceed with the course. Okay, now we will start with the development of the business intelligence systems. Unlike traditional development approach, where usually development of systems starts with business needs. From business needs, we do the project planning, and then we identify the functional requirements. Then we do system analysis, and then we do design. We develop the system, we test the system. There are several layers of testing, and then we will implement the system. After the system have implemented, we will do routine maintenance, periodic maintenance of the system. So, but for business intelligence system, it doesn't start with business needs. It starts with business opportunity. So we look at what are the opportunity that arise uh, that we want to apply our business intelligence. Business intelligence applications are mostly driven by business opportunity rather than business needs. So business intelligence applications will implement a cross-organizational decision support strategy rather than departmental decision support silos. It is cross-organizational, meaning that we don't really look at a single department, but we look at the whole organization, cross-organizational decision support strategy. So business information system requirements are mostly strategic information requirements. It is not operational functional requirements. It's more strategic requirements. How to make the organization strategize is knowledge needs, information needs, and then analysis of business in BI projects will emphasize on business analysis rather than system analysis. The emphasis is on business analysis. So then only we'll do design, and then the ongoing business application release will release evaluation to promote iterative developments, meaning that it will iterate from time to time. So we can see here it starts with business opportunity. So it is more of decision support strategies, cross-organizational decision support strategies. We do project planning, and then we identify strategic information requirements that we need to apply, and then we do business analysis. The business analysis emphasis compared to system analysis, and then we make decision. We design, and then we develop the system, we test the system, we implement the system, and constantly or periodically we do release evaluation, and we iteratively we upgrade the system from time to time. So this is the chart for cross-organizational development approach. We do business case, we do business cases so that we can justify the development of the system. We look at the business cases, and then we do planning. Yeah. In planning involve enterprise infrastructure evaluation, and then we do project planning, and then in business analysis begins with project requirements definition. We define the project requirements, and then we break up into three, which are the data analysis, application prototyping, and metadata repository analysis. Metadata is the data about data. It supports the data analysis. So relying on data analysis alone is not enough. We need to have a metadata repository analysis. So we have application programming there. And then with that, we will develop a database design as well as metadata repository design. Yes, database design and metadata repository design. Then we will design the extract, transform, and load ETL design. We'll design how do we extract data, transform the data, and load the data. And when we will do the ETL, extract, transform, load development, application development, data mining. So how we will mine the data, metadata repository, development, and then we will implement the system before implement the system. So then we will do even from the time to time we will have release evaluation, meaning that we have version 1 and then we upgrade and then we have version 2 and so on. So continuously we will upgrade the system depending on the business analysis and opportunity that arise, and then what kind of strategic information that we require. So the mainly the development approach will start with justification. We need to have justification of what we want to develop, and then we do planning. We emphasize on business analysis instead of system analysis, and then we will design the system, construct the system, and deployment the system iteratively. Okay, now we look into data warehousing. Business intelligence used to be everything related to the data, to the use of data for managerial decision making. So now it is a part of business analytics. So business intelligence is part of business analytics. Business intelligence is this part, which is the descriptive analytics on the past data, what has happened, what is happening, and then how do you build your business reporting, your dashboard, your scorecard, your data warehousing. Yeah. So now you can see clearly. Yeah, and then a well-defined business problem and opportunities. So from there, this is the part of business intelligence. Now, business intelligence is part of business analytics. Business analytics combined with predictive analytics and prescriptive analytics, where predictive analytics, we will look into what will happen, why will it happen, and then activities in or enablers in business analytics include data mining, text mining, web mining, forecasting. The goal is to project, to somehow accurately project future events and outcomes, and then we will make decision. In decision, we call it prescriptive analytics, also part of business analytics. What should we do? How should we do it? Why should we do it? And then we do optimization, simulation, decision modeling, expert system, and then the idea is to get the best possible business decisions and actions for our decision making. So what is a data warehouse? Data warehouse is a physical repository where relational data are produced, yeah, relational where a pool of data produced to support decision making. It is a repository of current and historical data of potential interest for managers throughout the organization. So data are usually structured, but nevertheless, currently with big data analytics, we also have unstructured data. It comprises of online analytical processing, data mining, querying, reporting, and so on. So these are the tasks that should uh, be able to be done in a data warehouse. So data warehouse is a collection of integrated subject-oriented databases, meaning it is based on subject, yeah, and that it is designed to support decision support functions where each unit of this data are non-volatile. Non-volatile means the data existingly in the data warehouse should not be changed. So at any moment of time, it should not be changed. So it should be always relevant. So meaning when there is error or corrections need to be done on the data, you should what you say, you should post another entry, a reversal entry. So this data need to be non-volatile, cannot be changed at any point. So historically, data data warehouse begins with mainframe computers where we have simple data entry, routine reporting, and primitive database structure. And then that is in 1970s. In 1980s, we have the advent of mini personal computer, business application for the PC. We have distributed database management system, relational database management system. And then we have the term business data warehouse coin. So in 1990s, we now have centralized data storage where data warehousing was formed. And then we have two different methods of developing data warehouse, Inman method and Kimball method. We will go through later what is Inman method and what is Kimball method. And then we have the enterprise data warehouse architecture design. So in 2000, we have exponential growth of web data. So with the advent of internet, we have exponential growth of web data. And then consolidation of data warehouse with the business intelligence industry. And then data warehouse appliances have emerged. So we have more applications that can use data warehouse. And then come the term business intelligence. Gartner coined the term business intelligence. Then with this data warehouse, we start to do data mining, we start to do predictive modeling, and we have a development of many open source softwares. So, and then we have cloud, we have software as a service, platform as a service. And so in 2010, we have with the large amount of data on the web. We are able to do analytics of the uh, data. They're coming from web, they're coming from sensors, they're coming from satellites. So we have structured and unstructured data. So we can do analytics of this big data. Big data means the data have volume, data variety, data comes in large, high velocity, and data have veracity. So, and data provides value. So from there, we have social media analytics, such as sentiment analytics, that we gather data from social media. And then we have from the contents in the web and contents that in text repositories, we are able to do web and text and web analytics. And then come the advent of tools like Hadoop, which came from the Apache Foundation. We have MapReduce. We have not only SQL. We don't really rely on for especially for unstructured data. We don't depend on relational database or SQL database. We have no SQL, not only SQL or not only structured query language. Then we are able to do processing of in-memory and processing of in-database analytics. So characteristic of data warehouse. Data warehouse is what we call subject oriented. What it means by subject oriented is data are organized by detailed subjects. Yeah, so data are in subjects, so such as sales, yeah, such as products, customers. So it obtain relevant information relevant for decision support based on the subject. Yeah, so subject orientation enables the user to determine not only how their business is performing, but also uh, why you need to analyze this data. So it depends on the subject. So a data warehouse it differs from an operational database, where operational database are more of handling and or capturing transaction or online transaction processing. Data warehouse does an online analytical processing. So with subject orientation, we will be able to provide more comprehensive view and more comprehensive analysis about on the organization from the perspective of the subject. And then integration is integrated, or integration is related to subject oriented. We view the subject, and then we integrate with other components. So data warehouse must place data from different uh, sources into a consistent format, so that they must avoid naming conflicts. So we have extract, when we have transform, we avoid naming conflicts, and then discrepancies among the units of measure, so that we can integrate the data from coming from different sources with another sources, so that we are able to analyze more effectively. So data is time series, so or time variant. A data warehouse maintain historical data, so the data are non-volatile. So every data coming in are stamped with the date. So as such, it will be able to detect trends, deviations, and long-term relationships. So we can do forecasting, we can do comparison, so which can lead to better decision making. So every data warehouse has a temporal quality, meaning that they has a quality in terms of time. So time is an important dimension for all data warehouse that you need to support. So it cannot, so the contents are timestamped. So that we can do analysis in various intervals. For example, like we can do analysis in daily, hourly, daily, uh, weekly, monthly, or yearly based on the timestamp. And then we are able to even look into this year and last year on the same date based on the time. And then uh, and then the third one, the fourth one is data need to be non-volatile, meaning the data cannot be changed or updated after it has been entered. So any data that is obsolete and changes are recorded as new data. So any data that comes in will be as new data. So whatever you want to do changes, wherever you want to do correction, you enter a reversal entry. Yeah, so this is and then data in the warehouse, we are able to summarize this data. Data are not normalized like when we learn relational database management system, we break up the data so that it can be normalized. We want to avoid many to many relationship. But in data warehouse, we put in all the data and data are not normalized. And then that the normalization is not like the normal curve in statistic. This is data normalization, yeah. And then metadata. Metadata is data about data. It explains the data. So when you have data, we have also metadata to support or provide explanation or description of the data. So in data warehouse, we include web-based data warehouse. We have relational and we have multi-dimensional data warehouse. And then it applies client server, real time, write time, and active. Uh, that uh, Inactive data. So data mart. Data mart is a small scale data warehouse. There are two types of data mart: dependent data mart and independent data mart. A dependent data mart is gets its input from the data warehouse. So it is meant for specific projects, specific function, for example, sales or finance. So it can process the data, analyze the data there, and then provide output back to the data mart. It is dependent to the data warehouse. Yeah. So it gets data from the data warehouse, it processed it, and then it analyze it. It can provide its own reporting, and then but it can also support back the data warehouse, but it is dependent on the data warehouse, main data warehouse. And independent data mart is not related, it's independent of the data warehouse. It's a small data warehouse for the specific unit, or we call it SBU, strategic business unit, or a department that is separated from the main data warehouse. It can be meant for a specific project that the company want to do, and then they don't want to get tied up to the or it is not related to the data that coming from the data warehouse, or does not contribute back to the data warehouse. It's independent. So other data warehouse components, we have operational data stores, is meant for operational system. And then in the operational data stores, we have which is we call operational uh, data mart. We call it Opera Marts. And then we have enterprise data warehouse, which is a data warehouse meant for the enterprise, and metadata, like which I showed in the early slides just now. We have a repository for data. We have data of metadata, which is data about data. It describes the content of data warehouse, the date and time acquisition, and so on about the data. Okay, data warehouse for data-driven decision making. So, data warehouse is meant for It supports data-driven decision making in this is an example in automotive industry. So we can reduce infrastructure expenses. Would be able to uh, you know, so produce warranty expenses, improve cost quality, accurate environment performance reporting, and provide IT architecture standardization. So this is an example of data warehouse to provide decision making. It is a data-driven decision making. Example here is in the making of the automotive industry, where we can with the use of data warehouse, the organization could reduce its infrastructure expenses, could produce improve reimbursement accuracy towards improve claim of data quality, and then improve cost of quality, and then provide accurate environmental performance reporting, and then there is standardization IT architecture. Okay, this is a generic data warehouse framework. You can see data sources come from ERP. We covered ERP in MIS, Enterprise Resource Planning System. There are also data sources come from legacy database, and then we have data data sources. Data come from the point of sales. Data coming from other online transaction processing. Remember, you have your transaction processing system, a web system where we can capture data online transaction processing data, and then we have on other external data. So from this data sources, it need to undergo the ETL process. ETL process is where ETL stands for extract, transform, and load. Yeah, extract, transform, and load. And the ETL involves selecting, extracting, transforming, integrating, and loading data. So we select the data from these various sources, which one we want to use, and then we extract them from the sources, we transform them into a specific or into a standard form or standard format, standard units, so that we can integrate them with the other data. We do cross-organizational, and then we load them into the enterprise data warehouse. When we when when we load into the enterprise data warehouse, we extract out the data metadata. We put them in a metadata repository. Then we can also have replication of data warehouse and metadata. So in case of these for redundancy purposes. So, and then organizations can also have data marts to what they call it, to support and to make more efficient analysis of smaller data sizes, so smaller, so that it can have data mart for marketing, just to do marketing analysis, data mart for operations, to just to do operations analysis, data mart for finance, and so on. And then from this data mart, uh, there can also be an option of and then they can also use this data from this data mart combined with an application programming interface or middleware to provide other applications for routine business reporting, data text mining, online analytical processing dashboard, web and custom built applications. So this the end, these are the users of these are the users of this data, the applications of this data. They're coming from this uh, data mart, as well as from the data warehouse. So without data warehouse, it can go straight to this application. Without data mart, the data from the data warehouse can go straight to this application, or it can pass through data mart first. It depends on the need of your organization. If your organization needs a specialized analysis of data for marketing, it will be passed to the that marketing data mart before goes to the middleware and API to be used in the applications. Or uh, if you don't require data mart, you can get access to the process analysis, process data or gathered data at the enterprise data warehouse. So the application of analysis is done here. So this is the data warehouse. So data warehouse obtain the data from the repository, from the sources, and then they will extract, transform, and load here, put them into data warehouse. This is large data warehouse, and then we have subunits which are the data marts. These are independent. These are dependent data marts. These are dependent data marts. It depends on the data warehouse, and then we have this API and middleware. It depends on the needs. Maybe you want to use web service, you want to use online uh, SOA and so on. So, and then you have applications here. Okay, now. So there are several tiers of architecture for data warehouse. We have three-tier architecture where we have data acquisition at the back end. We have central data warehouse and then client at the front end. Or two-tier architecture where the data acquisition and data warehouse are combined into one, and then we have client at the front end. Or a single tier where everything is in a single server. Single. So this is a three-tier architecture where we have client workstation accessing to the data warehouse, into the application server, and then we have database server here. Three-tier architecture. Or two-tier architecture, we have the client architect. The client is here. Yeah. Client workstation and application and database server is combined. Or one-tier architecture where everything is in one server. Yeah, data warehouse. So in developing a data warehouse architecture, you need to look into which database management system you want to use. You want to use Oracle, or you want to use Hadoop, or open source like MongoDB or PostgreSQL, or what sort of database management systems that you want to use. Whether you want to do parallel processing or partitioning, and then what kind of data migration tools that you will use in loading, extract, transform, and loading to the data warehouse, and what tools will you use to support data retrievals and analysis of your data. So this is a web-based data warehouse architecture. We have client using web browsers like we have Chrome or anything, and then we have internet or extranet, and then we have web server here, maybe Apache or Microsoft with a web server. Then we have web pages, we have application server, we have data warehouse. It's a web-based data warehouse architecture. Now we look into alternative data warehouse architecture. We have this is independent data mart architecture. Independent data mart architecture, we have source systems, which is a database data that the source database. It can be legacy system, it can be a relational database management system, it can be a point of sale system or anything, or even your ATM. That is the staging area where the data is extracted, transformed, and loaded, and then we have independent data mart. Yeah. And then from the young end user will have their access and applications to do analysis. And then there is the next is data mart bus architecture, where we have source systems, can be anything, can be point of sale systems, and then there is a staging area where you do the extract, transform, load, and you stage the data there, and then you can have dimensionalized data mart. It's based on confirm dimension. You have dimensionalized data marts. Yeah. And then we have end user access and application here. Here we don't have dimensionalized, so it is the data gathered, and then The third one is hub and spoke architecture. Yeah, where okay, go back to this dimensionalize this second one. Yeah, the purpose why we want to we the purpose of this data mart architecture, the advantage of this data mart architecture is because it can it has various individual mart, and then they maintain data consistency among the different enterprises, so it can allow data queries from one data mart to another data mart. Okay. In the hub and spoke architecture, this is most common and most famous data warehouse architecture today. So it focuses on building a scalable and maintainable infrastructure. So it is a centralized data warehouse. We have several data marts within it, and then for each organizational unit, you have a small data mart for finance, marketing, and so on. So it can allow easy customization of user interface within the different departments, so that for their different reporting or own reporting, and then it is more holistic, but it can lead to data redundancy. This is number three. Next is the centralized data warehouse. We have a large data warehouse, which is similar. It is similar like hub and spoke architecture, but there are no dependent data marts. There is no dependent data marts there. So you have a gigantic enterprise data warehouse, serve needs of all the organizational units. So it provides users with access to all the data within the data warehouse, instead of limiting them to the data mart. So the user doesn't go to the data mart. It goes to the main centralized data warehouse. So it reduces the amount of data technical team have to transfer or change, simplify the data management and administration. So it provides a timely, a more holistic view of this data. And then the fourth one is the federated architecture. It actually comprised of many data warehouses, many data marts, and many legacy systems. So they are federated. So it need to apply a standard approach. Usually we use extensible markup language XML based tools, so that we can access these distributed data sources, including data warehouse, website, document, operational system, and map them using metadata. Map them using metadata, so that users can have access to this data. So 10 factors that can potentially affect the architecture selection process. The 10 things that you need to look into when you want to identify what type of architecture you want to use for your uh, data warehouse. If you look into information interdependence between organizational units, whether you need to have data marts or you don't have data marts, whether there is interdependent information between the organizational units, and also rely on your upper management's information needs. What is the information needs from by up your upper management? Whether you require separate information needs for marketing, finance, or you need to have a centralized large data warehouse where you can consolidate everything, integrate everything together. And then it depends on urgency need of a data warehouse. How it's easier to develop a data mart rather than a large data warehouse. And then nature of end user task, what will be the end user task, what kind of analysis that you require, constraint on the sources, what sources can you get from the web, from the point of sales, from the machines, and so on, from your sensors, from the actuators. And then you need to look at to have a strategic view of the data warehouse prior to the implementation. You need to plan, and then you need to look into compatibility with existing system. Maybe you require some middlewares or APIs, and then perceived ability on the in-house IT staff. What is the capability of your IT staff in developing the separate data warehouses? Technical issues, and also social and political issues. Maybe there are detailed data which are more sensitive, so you need to aggregate the data in data mart level before passing them to main data warehouse before it being collected and processed and analyzed at a different department. So now we look into now we talk about data integration. Integration involves three major process. You need to have access to the data. How do you federate the data? And then you want to change the data. So ETL stands for extract, transformation, and load. So enterprise application integration is the technology that provides vehicles so that you can push data from the source system into a data warehouse. And then enterprise information integration, which where is the current tool space that promise a real-time data integration from variety of sources so that like a relational database, multi-dimensional database, web services. So you integrate everything so that it can be integrated into your data warehouse. So we have data integration, extraction, transforming, and load process. Yeah. So ETL have been there for quite some time, instrumental in the process and use of data warehouses. So ETL process is an integral component of any data-centric project. So it consists of extraction. We extract data, reading data from one or more databases, transform the data, meaning that we convert the extracted data from previous form to a form that it needs to be used so that it can place into a data warehouse or another data warehouse and load them into the data warehouse. Transformation occurs by using rules or lookup tables, combining data with other data. So these are the three main components of this data warehouse, which is extract, transform, and load. Of course, in the middle, we have cleansing of the data. Yeah. Issues that affect the uh, purchase of when you want to purchase a data ETL tools, transformation tools are expensive, so it can even the tools may have a long learning curve. So important criteria in selecting an ETL tools will be uh, the ability to read from and write an unlimited number of sources, how we could automatically capture and deliver metadata, not just data but also metadata, and the history of conforming to open standards like XML rather than using legacy system, and then easy to use interface for developer and functional users. So there are two approaches how do you develop data warehouse. We have the Inman model and also the Kimball model. Inman model is the enterprise data warehouse approach, which begins from the top down, and Kimball model is data mart approach, which is bottom up. So these are the comparing the two Inman model and uh, enterprise data warehouse uh, in Inman model and the data mart approach, which is the Kimball model. Okay, which is the best? The Inman model, which is the enterprise. Okay, we'll start with the data mart approach. Yeah, data mart approach here. Okay, the data mart approach, or known as Kimball model, is a plan big but build small approach. Plan big but build small approach. It is a subject-oriented or departmental-oriented data warehouse. Yeah, scaled down version of data warehouse, focus on the request of the need of a specific department, maybe it's marketing or sales, and then applies dimensional data, which starts with table and develop it. So whereas the enterprise data warehouse approach or the Inman approach, we emphasize top-down development. It look at establishing a database development methodology and tools such as entity relationship diagram, adjustment of spiral development. So it doesn't begin with data mart. The creation of data mart is actually begins from top to down. Okay, which model is suitable would depend on uh, your need and uh, your requirement, yeah. And then There is also hosted data warehouse, so you can put data warehouse in the cloud. It require minimal investment infrastructure. It can frees up capacity of your in-house or on-premises system, frees up your cash flow. You only pay when you use them, and then it can make powerful solution affordable, and then it enables solution that provide for growth. So this is on hosted data warehouse. And representation of data in data warehouse. How do you represent data in data warehouse? Then we can have several methods. Among them is the dimensional modeling, star schema, and snowflake scheme. So dimensional modeling is a retrieval-based system. It supports high-volume query and access, whereas the star system is the commonly used and most simplest style of dimensional modeling. So it is fact table surrounded by or connected by to various dimension tables, whereas the uh, snowflake schema is an extension of the star schema where the diagram resembles a snowflake in shape. So this is when you talk about the multidimensionally, you look multidimensionality. You look into the multidimensional presentation, which is dimensions of the. So, hold on there. I need to connect. Okay. When you talk about multidimensionality, we look at dimensions. We look at the dimensions. We need to break the dimensions of the data. We look at the product, salesperson, market segment, and so on. And then how do you measure the data, or how do you organize, present, and measure the data in terms of sales volume, headcount, and so on. And then in terms of the time, what is the date, whether it is daily, weekly, monthly, quarterly, or yearly. And then this is star schema, and then this is snowflake schema. Yeah. Star schema, sometimes we call it star join scheme. Star join schema is most common and simplest style of modeling. It has a central fact here, surrounded by, connected by several dimension tables, depends on the dimension that we pick up just now. And then a fact table provide the descriptive attributes to perform decision analysis and query reporting. And we have foreign keys. Remember, we talk about foreign keys and uh, primary keys. Yeah, how to measure, and then surrounding the the central fact table are the dimensional tables. These are the dimensional tables based on different dimensions that you want to measure. And then when you have a snowflake schema, we break it further. It's a logical arrangement tables where you it is a multi-dimensional table database. And then such a way that we look at the entity relationship diagram, ERD. Entity relationship diagram is how you break up your entity. I think we have covered that in our MIS class. Yeah. Then how comparing data analysis in data warehouse compared to OLAP and versus OLTP. OLTP is online transaction processing. It captures data from your transaction processes in your ERP, enterprise resource planning, CRM, customer relationship management system, point of sales. So main focus is to process the routine tasks. Whereas in terms of the uh, Whereas in the OLAP is about online analytical processing. How do you convert data into information so you can provide, can help you to make decision support. You look into data cubes, you can drill down, roll up, and you slice and dice your data. You can request ad hoc report. You can conduct statistical and other analysis. You can do development, multimedia-based application, and so on. Yeah, this is comparing OLTP and OLAP. The purpose of OLTP is to carry out day-to-day business functions, whereas for OLAP to support decision making, to provide answers to business and management queries. The data sources for OLTP come from your transaction database, whereas for OLAP data come from the data warehouses. OLAP operations, you can slice, meaning that you can break up the data into subsets according to this array, multi-dimensional array. You can dice them into more than 2 dimensions, or you can drill down, or you can drill up. You can roll up. You can compute the data relationship within one or more dimensions, or you can even pivot, change the dimensional orientation so that you can report or provide ad hoc, can answer to ad hoc query. So this is slicing. Yeah, and then so successful data warehouse implementation, things to avoid in successful data in implementing data implementation. You need to start, if you start with wrong sponsorship chain, if you set expectation that you cannot meet, if you engage in politically naive behavior, you load data warehouse with information just because it is available, and then believe that the warehouse database design is the same as transactional database. So the design of data warehousing database design is different from the transactional database design. So data warehouse need to be scalable. So main issues in pertaining to scalability is related to the amount of data in data warehouse, how quickly data warehouse is expected to grow, the number of concurrent users. It's at one time how would be the concurrent users, and complexity of the user queries. And then in terms of admin and security, we look into data warehouse administrator need to have knowledge on high performance software, hardware, networking technologies. They should have solid business knowledge and insight. Not just technical, but they also need to know business, have knowledge, business knowledge, and are familiar in decision making processes. Yeah, and then how you break even, how do you order economically, and so on. And then in terms of security, uh, data is most valuable asset, so you need to safeguard the data and comply with government regulations. Future of data warehouse, they will be have we will be more of we can source data from the web, we can source data from social media, Facebook, Twitter, Instagram, many forms of data, and we can get it from big data. And then you can use open source software. We will move towards the cloud. We can have software as a service, and we will move toward data lakes. Data lakes are larger than data warehouse. We put everything in instead of selecting the data, and then we can be in terms of infrastructure, we can use more of a columnar analysis. We can have real-time data warehouse. We can have many more data warehouse appliances. Data management practices can be improved, and with cheaper data processing costs, we can have in-memory processing. We have new database management system and advanced analytics. So this is data lakes and unstructured data storage. Yeah, meant for big data. Compared to big data warehouse, which is structured and processed, data lakes, any data can be put in. So there is no SQL, not only SQL. The retrieval will be a little bit slow because of it is not designed for, it is not structured. We first, okay, now we move into the next topic on business performance management. Business performance management is a real-time system that alert managers how to identify, detect, or potential opportunities or impending problems and threats, and then empower the managers to react effectively and efficiently through models and collaboration. So it is also called corporate performance management, or enterprise performance management, or strategic enterprise management. Yeah, so business performance management refers to the business processes, methodologies, metrics, measurement, technologies that are being used by enterprises. How do you measure, monitor, and manage business performance? So there are three main components for this business performance management, which are the integrated closed loop management and analytic processes. Okay, these analytic processes are supported by technology, tools for businesses to define their strategic goals and measure and manage performance, and also method and tools to monitor key performance indicator linked to organizational strategy. Yeah. So we go towards a closed loop process to optimize business performance. So the first stage is there is it is the first stage we look at is strategize. Strategize in general terms is how a high level plan of action. So it is long term, long periodic type of time to achieve a defined goal. So specifically, it is a process of identify and stating the organization's mission, vision, and objectives, and developing plans how we will achieve them based on different levels of granularity. It can be strategic level, tactical level, and operational level, meaning that at the top it will be the strategic level making the decision, and then pass down to the tactical decision how to carry out, how to do the task, and then implement it at the operational level. So that is the strategized process. Yeah, strategized process. The next process is the planning process. Planning, how do we get there? How do we can have financial plan, we have budgeting process, and we have operational plan. The operational plan will translate the organization's strategic objective goals into a well-defined tactics. Yeah. And then we will monitor and analyze how do we do that. And then when operational are in the process, so we need to measure and monitor our performance. What first we need to know what to monitor, and then how to monitor them, what measurements we need to take. So these measurements are called key performance indicators. So this is part of your uh, assignment for this course. And then act and adjust, how do you adopt and act and adjust? So with yeah, so how do you streamline the process? Yeah. Okay, we go detail after this. So strategic planning, common task for strategic planning will do a current situation analysis, determine the planning horizon, where do you want to plan towards, and then do an environmental scan, identify the critical success factor, complete a gap analysis, create a strategic vision, develop a business strategy, and identify your strategic objectives and goals of the organization. Now we move into operational planning. Operational planning will translate an organization's strategic objective into goals, set of well-defined tactic, initiative, resources, what are the resources that you require, and then planning. Operational planning can be tactic-centric, which is operational focus, or budget-centric, which is financial focus. Third is monitor and analyze. How do we do? What do we monitor? What are the critical success factors? What are the KPIs that you need to look at? And then what are the strategic goals and targets, and how to monitor them? What measurements that will use, your KPI that you will use in the tools in measuring them. Yeah. And then you will act and adjust. Yeah. So how do you create new product? How do you enter the market, acquire new customers, streamline the process? So how many so this is you act and adjust differently. So that to achieve your goal. Then you will do performance management. Performance measurement system is a system that assists managers in tracking implementation of business strategy. It comprises of systematic comparative method that indicate progress. Yeah. So KPI is the key performance indicator, a strategic objective and metrics. How do you measure your performance against goal? So how do you distinguish features of KPI? You look into the strategy, what is the target, what is the range, how do you encode them, encode the target. Yeah, so encodings are ranges in so that you can have visual display. You can make it color red, blue, or green, and so on. And then what is the time frame? What is your benchmark or baseline for your KPI? Yeah, and then the outcome KPI, the operational areas can be covered by KPI. For example, customer performance, service performance, sales operations, sales plan, and sales forecast. Yeah, balance scorecard is a performance management system that translate not just the financial but also the customer internal processes and also learning and growth objective of the organization. So it comprises of four components. Only one which is financial perspective. The rest is the internal business process. How do you your how effective is your business processes, your function and outcome of these processes, whether you meet the expectation of your businesses, and then your learning curve, how do you train your staff, employee training, knowledge management, corporate culture characteristics, and then your the customer perspective. Customer perspective, you look into the customer satisfaction. How satisfied is your customer, and then only one part which is the financial perspective. Yeah. So the financial performance, the profitability, cost benefit analysis, cost benefit data. So Six Sigma is another business performance methodology that reduces the number of defects. It look into defects per million opportunities. Look into defects. We have the Mike performance model, closed loop, where you define, measure, analyze, improve, and control. So define is where you define the goal, objectives, boundaries of the improvement you want to do. Measure is you measure the existing system, establish quantitative measures that will yield statistically valid data. Analyze, we will analyze the system to identify ways how to eliminate gap between the current performance process and your desired goal. Improve, how do you initiate actions to eliminate the gap, finding ways how to do things better. And control, how do you institutionalize, improve system by modifying compensation, incentive system, policies, procedures, resource planning, budget, operation instruction, and so on. So this is GMI. Lean Six Sigma is another um, method where it is based on lean manufacturing or lean production. Okay, we will go detail. Comparing the balance scorecard with Six Sigma, yeah. Six Sigma is more of performance management system, whereas Balance Scorecard is strategic management system. Six Sigma provides snapshot of business performance and identify measures that drive performance towards profitability, whereas Balance Scorecard relates to longer term view of the business. And then Six Sigma is designed to identify set of measures that impact profitability, whereas Balance Scorecard is to develop a balanced set of measures. So you can go detail, you can read the detail of this. Yeah, so Six Sigma works toward focusing on maximizing profitability, whereas Balance Scorecard focuses on growth. So, when you want to measure effective performance, you need to look into key factors. You should have a mix of past, present, and future. You should balance between the needs of shareholders, employees, partners, suppliers, and other stakeholders. How you start from the top, and flow to the bottom. And then you need to have targets that are based on research and reality rather than just arbitrary. Okay, we have done with our topic 2, business intelligence and data warehousing. So thank you very much for attending my course. So we will continue with the third topic in coming next video. Okay, thank you.